Hello everyone, welcome to my YouTube channel. Today we will discuss a very important topic in DevOps world, that is Kubernetes. Okay. So what is Kubernetes? Kubernetes is a container orchestration platform, right? What is container? Container is nothing but your applications. And what is orchestration? Orchestration means management of apps, right? So what is Kubernetes? Kubernetes is a tool which manages your applications, right? So Kubernetes, just for information, it is a open source tool. It is developed by a company called CNCF, means Cloud Native Computing Foundation, right? Okay. So before starting further, we need to understand why we need, like, what is the need of Kubernetes, what problems it is resolving, like what problems previously were there, and what it is resolving. Okay. So right. So first we need to. You might have heard about this Docker, right? What is a Docker? Docker is a build tool. It is used to build Docker images, like images of our application. Like, so there are some problems in Docker which are Kubernetes is resolving. So what are the problems in Docker? Okay. So I will first tell you a complete flow, like what happens in, like, complete the continuous integration and deployment process, CI/CD process. Like, okay, so we have our application code base, right? Then what this does, a DevOps engineer comes and build the Docker image of it. This is a Docker image. Now what happens? We need to run this image on the server. So there is a server. Okay, this is server. Now in this server we need to run these Docker images. So these images are running, right? In server contains container runtime environment. What it is? It is an environment which provides all the facilities so that a Docker image can run. We know that Docker image is a static, right? It it is a static. It is in a static state. It is not running. When the container runtime environment runs this static image, then this is called containers. So if someone asks you what are containers, containers are nothing but they are a running instance of our images. Running instance of images, right? Okay. So let's get back to the topic. Okay. This server contains container runtime environment. So these containers are running. Now by somehow logic, our user is here. It want to access this application. We expose this application somehow. I'm not going into details of Docker, but application is exposed and the user is able to access it. Okay. Now one more user come, means traffic is increasing, right? So these containers, there are only two containers here. Now let's say they are not able to fulfill the traffic. We need more running containers inside the server. So what can the server has the capability to run the instances or the containers again, means by itself? No. Manual intervention is needed there. Whenever as the traffic increases, a DevOps engineer has to come and increase the number of instances here. It is a manual. So what problem in this is, as the traffic increases, manual intervention is needed, right? And similarly, as the traffic decreases, the DevOps engineer manually needs to decrease the instances here. So there is a scalability issue, like, right? Now what other issue it has? A term is known as auto healing. Okay, what is auto healing? Let's say somehow some error occurred and your this two containers are there, both containers got down, so your service is unreachable to the users. Okay, so the server or this Docker environment don't have this capability to run these containers again by itself. It can't run it again. Manual intervention is needed. DevOps engineer will come, it will rerun, it will see, okay, the containers are stopped, he will rerun it again, right? So it doesn't have this auto healing. Auto healing means a server should have the capability to check if the pods are not up, containers are not running, it will rerun it on itself again. Okay, right. Fourth problem is enterprise level, like, softwares. Like, we can't build only enterprise level softwares only with Docker. Why? Because what enterprise level needs? They need security. Security, like firewall rules are needed, right? Gateways are needed. I will discuss these terms afterwards, but let's say only Docker is running here. We don't define security, like who can access this application, and firewall rules are also not set up. So for enterprise level, only Docker will not work. Docker with some other technology can work, but only Docker will not work. Okay, so these issues our Kubernetes is resolving. How it is resolving, we will discuss that. So first we will discuss the complete Kubernetes architecture, how, and then we will go into detail, right? Okay, Kubernetes architecture. Okay, so we will now discuss about Kubernetes architecture, cluster architecture. Okay, so yes, we'll start Kubernetes architecture. So what is there is what is Kubernetes? Kubernetes is a cluster, right? It is a cluster. So cluster, what is cluster? Cluster is a group of nodes, or we can say group of virtual machines. Okay. So let's say this is our cluster. This is cluster. What is a cluster? Cluster is a group of nodes. Nodes meaning you can say just virtual machines. What are virtual machines? Just small computers. Very basic. Okay. Now this cluster contains one master node and many worker nodes. Master nodes can be more than one also, but the count of master nodes would be less than the worker nodes only. Okay. So this is master node and worker nodes. Now master nodes has some set of functionalities, worker nodes has some set of functionalities. Now we will discuss, this is a high level architecture, right? This master node is also known as control plane. Okay. So this control plane has some functionalities. We will discuss about these functionalities and also about functionalities of these worker nodes. Okay. Okay. So here is the architecture of the Kubernetes cluster. This, okay, that I got from this Kubernetes documentation. Okay, so you see, control plane is there. This one, I will change color. 1 second. Okay, this control plane. This is our master node that I discussed previously, and these nodes are worker nodes. Okay, so what this master node is containing? So master, what does master node contain? You can see it has Kube API server, it has etcd, it has a scheduler, and two more. Okay, you can see two more are this. Okay, let me write it. This is control manager and cloud control manager. Now we will discuss about each of these functionalities. What is Kube API server? Okay, we will discuss about this each of these components. First we will discuss about this Kube API server. Okay, so Kube API server. So what it is, you can see in the name it is an API. Okay, so I will give you an analogy so you can better understand what happens in normal development. Development is developer develops the code. In code, what is written? In code, APIs are there. So what are those APIs? APIs are a way to access the backend application, right? Backend code. Like some logic is there in the backend code that through the APIs a user is able to access. Correct? So this is the, now what happens in Kube API server? We have a Kubernetes cluster. Okay, master node. Now master node, this Kubernetes contains many functions inside, or many functionalities are there. Okay, now this Kube API server resides here. Kube API server, it is a way to access these resources. Like this, you can say some kind of code is written to create some kind of resource in a Kubernetes. I will explain it again. What in Kubernetes, like we need to various objects are there, right? Let's say objects. What are these objects? Like when we deploy application, we do deployment. Okay, we create services. All of this would be, I will be discussing in the next videos in detail. We create gateways, but for the high level, we create service accounts. Okay, many things are there. So code is written so that if a DevOps engineer said I want to do a deployment, like then how this Kubernetes will know that a deployment has to be made? Some APIs or some matching or some mapping needs to be there, na? So Kube API server contains all those. It acts as a mediator between the DevOps engineer and the resources that needs to be created. Okay, like Kubernetes created some APIs that its DevOps engineer will access to create these kind of resources. Understood. Okay. So, okay, I'm explaining only like you write Java code, you write Python, Angular code. Okay. So similarly, in Kubernetes, the language is YAML. We write YAML files to create deployment, to create services, to create gateways, to create Kubernetes objects. We use YAML file. Okay. In YAML file, we specify kind. If you are not able to understand in detail, I will discuss in next videos, but just for understanding, so that you could easily understand what is Kube API server. Okay. Some variable is their kind, that this kind can be of deployment, this can be of services, this can be gateways, this can be service account, this can be any object, this can be firewall rule. Okay. So Kubernetes reads these YAML file, reads this kind. By this kind, he is able to understand which resources to create. Like by kind, he will go to this Kube API. Sorry. Okay. We'll go to this Cube API and get to know which resources to create. Okay. So Cube API is just API. It will again DevOps engine, DevOps is there. DevOps will write YAML code. YAML code will contain kind. Kind can be of any of these types. So how does Kubernetes know which resource to create? It will go to this Cube API. It will read the kind and then similarly create the resources. So this is the Cube API server. Now we will discuss of the about next thing, that is etcd. Right. Okay. So etcd. etcd is nothing. Etcd is a database, like a very high available database. High availability. High available means very fast database, or we can say these values are fetched from the cluster very fast. You can say, or it is very resilient or very reliable. So or whatever the database that mm, cluster is using. Database means what cluster can store in database? Secrets, right? Config maps. We'll discuss about these in next videos, but for high level, just understood that etcd is a kind of database that cluster uses. Okay. We will go to next thing now. Okay. Now other component is cube scheduler in master node. What cube scheduler is does? By name we understand scheduler is present. So what does it schedule? Okay. It schedule the incoming pods, right? You have a cluster. Okay. Cluster had some nodes. These are nodes. These are worker nodes. Okay. Now developer develops one application, wants to deploy these his application of worker nodes. Okay. So where scheduler comes? Scheduler comes in between. What it does is it allocates the pods, it allocates the nodes to the uh, application, right? Whenever a new application is pushed to the cluster for deployment, it cube scheduler finds the particular worker node which is free, schedules the pods inside this worker nodes, right? Okay, so it is a scheduler only which schedules the applications or new incoming pods and attach it to the nodes, so it can run on the inside the worker nodes. Okay. Now the next is controller manager. By name you can see controller is there. It controls all the major all kind of operations that are there happening in the cluster. Like it has controller manager, it has various controllers, like controllers we can say job controller, like, and scheduler controller, or namespace controller. What is the meaning? Means any new, let's say a DevOps engineer comes and said, I want to create a new deployment. Okay. So it okay. So it says I want to create a deployment, or I, let's say, leave deployment. Our engineer, DevOps engineer said I want to create a service account. Okay. So service account controller is there. Service account controller. Okay. So in this controller are the basic processes. Okay. You can say these kind of big processes are there, or we can say a daemon. What is a daemon? Daemon is a background process, a process that is running in a background for very long time, like continuously it runs. So request for service account creation came, it with controller manager will see, okay, we want to create a service account. How will it run? Like you have a study like Kube API server. Yes. So by kube API server, it will identify, okay, we need to create a service account. So kube API server will tell the controller manager that you want to create a service account. Okay, so controller manager will go to its service account control manager. Now service account control manager will create a service account. Now if the request comes for creating a namespace, then again namespace controller will work. Okay, so these are controllers are nothing but, you can say, big processors that are running in the background of the cluster, that are handling the request of creating the objects. Okay. Okay, now the only one thing is left in master node, that is CCM, that is cloud controller manager. Okay, so you have created a cluster, right? Your applications are running in it. You have master node, worker node, and worker node is running the applications. Okay. One thing is important to note here is, just besides the topic of this, all the applications that are running, right, whatever the applications or containers we are running, are always on the worker nodes. It doesn't run on master node. Master nodes only orchestrates the, means, manages the application, but the real application that runs on are on the worker nodes. Okay. Just for understanding, I said, okay, let's get back to cloud control manager. Okay, so cloud control manager is, okay, you created a cluster, your applications are running, but this is complete isolated, right? Isolated means there are three big providers in cloud, like AWS, Azure, GCP, and many others. Okay, so cloud controller manager, the task of cloud control manager is that it exposes your cluster to the outside world. Means, it if it is created on GCP, it will connect to GCP, that okay, in GCP this cluster has been created. In, if it's AWS, in AWS this cluster has been created. Okay, so the cloud control manager is of the task of this. The task of cloud control manager is to expose the cluster to the. It provides APIs to interact with the these service providers, cloud service providers. Okay. So now the master nodes are done. Now we will discuss about worker nodes. Okay, so worker nodes worker nodes has mainly three components. First is kubelet, second is kube proxy, and third is container runtime environment. Okay, so as I discussed previously also, that your applications or containers always run inside worker node. Okay, so what is the functionality of this kubelet? So kubelet, what kubelet does is, it continuously polls the status or checks on the application, that what is the health of the what is the health of the application that is running. If it is stopped, it will restart it again. Okay, so this is the task of the kubelet, to continuously check the health of the containers, and if it is stopped, and running, and continuously check the like, these are the pods, right? Pods have, like I mentioned, these are the deployments. So some configurations are there. So if somehow some configurations got mismatched, then the kubelet also checks these configurations. Okay, if configurations are mismatched, like here I define, I want two copies, two replica sets, like two replica sets, but here it's present only one, let's say, then it will create one more container. So kubelet also uh, tries to, whatever is defined in the config file of that deployments, it will continuously check that, and if it's there, if any mismatch is there in the current Kubernetes cluster of the application, okay, it will sync those. Okay. Kube proxy contains networking configurations. Networking configurations. Okay. Means you have a pod, right? When we do a deployment, it is a pod. So assigning IP addresses to each of the pod is done by the kube proxy. So this task is done by kube proxy, and like mapping of services, right? There are services are, I will discuss in next video. Services are there. So which services map to which pods, and all the network related configurations on high level, we can say, are managed by kube proxy. Now third is come to container runtime, that I discussed in starting. It provides a runtime environment for the Docker image to run. Okay, we know that image is there, Docker image. It is a static. It can't run on its own. It needs a container runtime environment to run inside any of the pod. Right? Like this is a pod. This is, let's say, a worker node is there. In worker node, our application is running. Inside it, this is a pod. Okay. So this node contains container runtime environment, so that whatever the Docker image comes, it provides environment, it can run this. So the Docker image can be converted to the container. Okay. Yes, so I think this much only. I pretty covered all the topics of the and the complete architecture of this Kubernetes. If you have any doubts, please put it in comments. I know my handwriting is very wrong, very bad. Sorry. So I'm just learning. So okay, I will keep improving this handwriting and keep try to make better diagrams. But if you have any questions, you can post in the comment section. I will answer. Thank you, and we will meet in the next video where we will discuss about pods, deployments, and services thing. Okay. Thank you.